Hello everyone, today our group would like to explain about the exercise from formative practice exercise 5.3. Now let us discuss the question 1. The diagram on the right shows a standard normal distribution graph. The probability represented by the shaded region is 0.3415. Find the value of k. First, we need to know that the total area under the graph is 1 unit. So half of the graph is 0.5. Then we can find the normal distribution of z smaller than k is 0.5 minus 0.3415, and the answer is 0.1585. Then we can go to the table of normal distribution. We can find that the k is equal to negative 0.1001. Now we go to the question 2. S is a continuous random variable that is normally distributed with a mean of 12 and a variance is 4. Find the z-score if x is equal to 14.2. Through the question, we can know that the mean is 12, variance is 4, and x is equal to 14.2. Based on the formula, z equals to s minus mean divided by standard deviation. So we need to find out the standard deviation. So we use square root of 4 so that we can find the standard deviation is 2. Next, we sub all these numbers into the formula and we can find z is equal to 1 by 1. Now we look at the question B. We use the formula. The same thing, we use the formula z equals to s minus mean divided by standard deviation, where s equal to 1 minus 12 divided by 2, and the same one 13.5 minus 12 divided by 2, and we can get the answer negative 0.5 and 0.75. Now we can draw a graph which presents the probability where we put 0.75 at the right hand side because it is positive, and we put negative 0.5 at the left hand side as negative 0.5 is negative. Now what we need to do is find the probability of this shaded region. And we all know the probability of O graph is 1, and we use 1 to minus these two numbers that we find at the table of normal distribution, so we can get the answer 0.4659. Now we go to question 3.
Let us move to the question 3. First, we can get the question from title. Probability of z is between m and 2 and 0.5 equal to 0.5124. And then we need to find out the value of m. We need to find out the normal distribution of 0.35, and value of normal distribution of 0.35 is 0.3632. We can find this value from standard normal distribution table. After that, we need to use 1 minus 0.3632 minus m equal to 0.5124. So so that we will get the value of m. And why we need to use 1 to minus is because the total area under the graph is 1 unit. Next, we move to the next question. From the title, we can get the mean is 3.1 kg. The standard deviation is 0.3 kg for the normal distribution. And let S equal to the mass of the baby. Then from the question, we can know the probability of mass for the baby is between 2.9 kg and 3.3 kg. Then we can use formula that equal to S minus mean divided by standard deviation to standardize S to Z. First process the formula 0.9 minus 0.1 divide 0.3, we will get minus 2 divide 3. We will get minus 2 over 3, and 3.3 minus 3.1 divide 0.3, we will get 2 over 3. The normal distribution of 2 over 3 is 0.2523. As we know, the probability of that is greater than minus 2 over 3 and less than 2 over 3. So we use 1 minus 0.2523 times 2. We will get the answer is 0.4954. Let us move to question B. For the question, we can get 0.25 of baby is underweight, and we need to find the maximum mass for the categories. So we can get probability of S is less than M and equal to 0.25. We need to standardize S to Z. So M minus 3.1 divide 0.3 equal to 0.25. The Z score of 0.25 is 0.674. As it at left hand side, we need to put negative in the front. And we calculate, we will get the value of N is 2.898 kg. And next,
We move to the question number 5. It is given that the mean of the masses of fish is 650, and S is the mass of fish. The probability that the fish caught randomly has a mass of less than 600 grams is 0.0012, and the S value is 600. Convert the normal distribution into the standard normal distribution, and we can find the value of Z score, which is the normal distribution, is equal to 3.034 by using the standard normal distribution table. As we refer to the standard normal distribution graph, Z score is located at the left side of the graph. So there's a negative value for Z score, which is negative 3.034. Once we get the value of Z score, we can find the standard deviation, which is P, by substitute all the information into the formula of Z score equal to S minus mean and divide by the standard deviation, which is P. Thus, the value of P is equal to 16.48. Next, we proceed to the question B. The question states that there are 350 fish have masses between 644 grams and 616 grams, so that the two S values are 645 and 616. From the previous question, we have found that the standard deviation is 16.48 and the mean is 650. In order to convert normal distribution to standard normal distribution, we have to find out the Z score by substitute all the information into the formula as same as the previous question. After that, we can get two values of the normal distribution, which are negative 0.303 and 0.607. the graph of standard normal distribution is constructed, and the probability of the continuous random variable z can be obtained by finding the area under the curve between two normal distributions. Probability of normal distribution smaller than -0.03 and greater than 0.607 can be determined by using the standard normal distribution table, which we can get the value of 0.3810 and 0.2720 minus the total area under the graph, which is 1, with two probabilities that we have found, so that the probability of the variable z is equal to 0.347. Thus, the total number of fish in the pond can be determined by using the formula of probability. By using the outcome 315 divided by the probability of the outcomes, which is 0.347, so that the total outcome is equal to 1009. Thus,
Question number 6. The daily wages of workers in a factory are normally distributed with a mean of 80 ringgit Malaysia and a standard deviation of 15 ringgit Malaysia. Given that the number of workers in the factory is 200, find the number of workers whose daily wages are more than 85 ringgit Malaysia. From the question, we know that the mean is 18, standard deviation is 50, and the number of workers is 200. In order to find out the number of workers whose daily wages are more than 85 ringgit, the first thing we need is the probability of X larger than 85. In this case, X represents the daily wages of workers, given that the daily wages of workers are normally distributed. So we have to convert the variable X into Z-score using the formula Z is equal to X minus mean over standard deviation, and the value of Z-score is 1/3. The probability of X larger than 85 is equal to the probability of Z-score larger than 1/3. As we can't find the probability of Z-score larger than 1/3 directly, we have to write 1/3 in 3 decimal places, which is 0.333, and we'll get 0.3696 from the standard normal distribution table. Then we multiply the probability with the total number of workers, and the answer is 73.92. Since we can't have 73.92 workers, so we round it off to 74 workers, which is the final answer. Section B. Find the value of P if P% of the workers in the factory earn less than 85 ringgit. From the question, P% is actually the probability of X smaller than 85 in percentage. As the total probability of an event is 1, we can just calculate the probability of X smaller than 85 by simply subtracting the probability of X larger than 85, which we have in section A, from 1. So 1 minus 0.3696 is 0.6304. As we mentioned earlier, 3% is the probability of X smaller than 85 in percentage. So we multiply 0.360 with 100% to get the value of P%, which is 63.04%. And we get the value of P is equal to 63.04. That's all. Thank you.